Okay, well, how's everybody today? Good, good, good. I'm doing well. We are very close to our 3-day weekend. As I said earlier, we should be able to wrap up currency conversion in probably about 10 minutes at least. Go ahead and start looking at simple and compound interest after that. Remember, tomorrow you've got your quiz over systems of equations and quadratics. Okay. Then next week we got our test coming up on Thursday. Does anybody have any questions about what's going to be happening? No?
Can you repeat what it is?
The test. Okay, so what will the test cover? What's one topic? Geometric sequences and series will be on there? Currency conversion? If there's one in the problem, you'll be provided it, yes. Okay. Arithmetic won't be on there. Okay, but you will have systems on there, quadratics. I did not put any of those on there, no. Okay. Systems of linear functions, quadratics, and because we are starting simple and compound interest today, I'm very optimistic we should be able to get that done before Thursday of next week. Okay, so we'll kind of see how that works. Hopefully this is another review item for you. And before you take off today, I've also got your next homework assignment. It's going to be over the currency conversion. We'll have that due Tuesday. I'll pass that out last thing. All right, so let's see. If you remember yesterday, you might recall that I blew things out of proportion. Because we're proportions. Anyway, I thought it was clever. Okay.
I did not sense that one.
To coin a phrase. Okay. All right, so we finished up with this example right here. So number 2, buy and sell values, or did we get that done? Did we actually do that one? Okay, but we didn't get to this next example. Okay, so our buy and sell rates. Did we get to talk about those? Okay, so the bank sells you foreign currency at a particular rate. If you're going to go, visit another country and you need the currency of the country you're going to, it's a very good idea. Now, it's always the lower rate because the bank doesn't want to give you as much money for every 1 unit of currency you're exchanging. Okay, the buy rate, well, let's say you come back from visiting another country and you have some of that currency left over. You want to be able to exchange it back to United States dollars. So the bank buys back your foreign currency at this rate, and it's going to be higher because the bank wants to get the most foreign currency for every 1 unit of currency you're going to be getting back. You remember I mentioned yesterday that the bank is a business, and they're in the business of making money. They're going to go ahead and take the money that you deposit with them, and they're going to make money off of that. They're going to make their own investments. Okay. Example, a currency exchange service exchanges €1 for Japanese yen using buy at 135.69. We're going to sell at 132.08. Cedric wishes to exchange €800 for yen. How many yen will he receive? Well, when you're setting up these proportions, remember you have the one fraction that is the conversion. Okay, in this case from euros to Japanese yen, and then we have the amount you're wanting to exchange for the amount you're going to get. Okay, so we're going to exchange, we know that €1. Now, which one am I going to use, the buy or the sell rate?
Sell.
The sell, because this is the price that the bank's going to give me when I'm changing that particular amount. So 132.08 yen equals. Now, what's going to be my other ratio?
Wouldn't it have to be euro to dollar? Because you don't have the direct conversion of yen.
Well, no, but this is the rate that the bank is providing. So this is what we were talking about a second ago. Yes. Mm-hmm. Yes. Mm-hmm.
So then the other one would just be.
And we're wanting to exchange how many euros? 800. 800 euros for X yen. Okay. Does everybody have any trouble setting up the proportion? Okay. Now we go ahead and cross multiply. So it looks like we just want to take 800 and multiply it by 132.08. Okay. So can anybody help me out with that?
105,664.
Yes, that's what I got. 105,664 yen. Okay. Now I'm going to be relying on you guys to go ahead and give me the answers, and I'll tell you if my answer matches up or not. Does anybody want to see me type it in the calculator? Yeah, you're just multiplying simple proportion. Okay. Yeah, go for it.
Would dimensional analysis like work for this type of problem? Because you're just converting from one unit to another technically.
Like you were saying a moment ago, if you wanted to convert euros to US dollars and then US dollars to yen.
You didn't have like the yen to euro directly. You could just do like euro to dollar and then dollar to yen.
I don't see why not. As long as you set up your ratios correctly so that, say, the US dollar's canceled,
Yeah.
I don't see why that wouldn't work. I think it should work just fine.
Yeah, I actually just did yeah.
Okay, good. All right, so B, if the yen in part A is converted immediately back to euro, how many euro are bought? Okay, so let's say the person went ahead and made this exchange, trip fell through, whatever the case is. So now we have to take the 105,664 yen and we want to get our euros back. But what's the issue? There you go. See, the bank is going to buy it back, but at a higher price. So am I going to go ahead and get back the 800 euros? No. We haven't even talked about the commission. That's just the exchange rate here. Does that make sense? Okay. Now, a lot of people have already told me what I need to do, but if I were going to set up our proportion, we know that 1 euro, and this time is going to be 135.69 yen, okay, is equal to X euro, because we're getting our euros back, over the 105,664 that we just received. So in this one, yes, you are going to have to divide the 105,664 by the 135.69. Okay, so what should I be getting? How many euros?
778 and 72.
Okay, there we go. That's what I got. So 778.72, and I don't know, like I said, the denominations over there. I'm just going to go ahead and keep it as a decimal because that's currency. Okay, but whatever their smaller denominations are. Okay, there you go. Is everybody okay with that? Now it goes on to say, C, what is the resultant commission on the double transaction? So because of the buy and sell rate, see, we did lose money. So how can I find out how much this person was charged to do this? Yeah, go ahead and just subtract the two. We started with 800 euros, and then we went ahead and subtracted 778.72. If I were to immediately convert it back, and how much did it cost me?
About 21.28 euros.
There you go. Well, you're a really mean person. Oh. I'll have to make a mental note of that joke. Because notes of money in some other places. Anyways, okay. Well, we are almost done here. Here are my last two problems, and we'll see if we can't get some folks up here to kind of help me out, because I've been doing a lot of these. So number one, given that one South African rand, and I'll go ahead and put the abbreviations here, that is ZAR, is equal to 0.2754 in Singapore dollars. Okay, so SGD. Find how many Singapore dollars you could buy for 2,500 South African rand. All right. So again, just a proportion. They're giving you the conversion right here. Okay. So all I need is somebody to come on up, show me the proportion, and we'll get the value. Any takers? Or do I need to go with the random number generator? Oh, John, you want to go?
I think I can.
Okay. All right. Sure. What'd you do?
I did 2,500, and then I multiplied it by 4, and that got me 600.
688.5 Singapore units of currency. I guess Singapore dollars. Okay. What do you guys think? That is perfect. Yes. Okay. Because when you set up the proportion, you'll actually be multiplying those together. Good. Did anybody want to see the proportion? Yes. Okay. All right. Good. 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 So here's what I had written: 1 South African rand. Okay. Over, we have this exchange rate here, the 0.2754 Singapore is equal to. Now we have 2,500 South African rand that we want to go ahead and figure out what that is in Singapore dollars. And there we go. You'll notice as soon as you cross multiply, you do get the product of those two. Okay, good. Very good. Okay, number 2. This is our last problem, and we are done with currency. Okay. A bank exchanges U.S. dollars for a commission of 1.8%. A customer wishes to convert 400 U.S. dollars to Mexican pesos for a trip. First, what commission is charged, and how many Mexican pesos will the customer receive? Right. So who wants to come on? Well, I'll tell you what, I'll even take care of the first part for you. Okay. So I'm wanting to convert 400 U.S. dollars. Okay. So I'm going to go ahead and multiply that by the percent we have, so 0.018. And what's that going to give me? Yeah, I got $7.20. Okay, so it's going to cost $7.20 to go ahead and convert that. Now, what's the amount that I'm actually going to go ahead and convert? Oh, there you go. I got 392.80. 392.80 is what we're actually going to convert. And remember, again, we talked about this yesterday. You could take the percent after you convert to Mexican pesos, and it's still going to come out the same. Okay, because these amounts are equivalent. Okay, so all we need is a proportion and eager volunteer. Gabby? All right. Okay, so 1 US dollar is 18.9032 Mexican pesos. And we're going to go ahead and convert 392.8 US dollars to X Mexican pesos. There you go. Okay, and someone want to help her out? What should that be? Okay, did you hear what he said? 7,425.18 Mexican pesos. That is correct. Okay. Correcto? How do you say correct in Spanish? Cierto?
It's true.
Cierto? Cierto? Cierto. Cierto. I'm not saying this right. Okay. Cierto. That's why I took French in high school. So living in West Texas and ultimately teaching in a high school, I took French instead of Spanish. Okay. All right, so there is your homework assignment over currency conversion. This will be due when? Tuesday. So you got plenty of time to go ahead and, take a look at it. All right, well, let's put our currency lesson to the side. Current lesson. That's kind of a stretch, but you get it. Okay. Current currency lesson. Yeah, you'll laugh later. Okay. Well, I said let's put our currency lesson to the side. Let's put our current lesson to the side. It's funny, Sydney. Okay. So, did I have these? Did I not have these out when you came in? Okay. Let me go ahead and pass those out real fast. And we'll probably only be able to do maybe a couple of examples, but at the very least, we'll have been able to start it. I've always found this particular lesson pretty interesting. Interesting. You know, I work really hard at those.
I mean, I hope it's not, no, it's I hope it's not too simple. It's not good.
Uh-huh.
So you like 3.
All right, so there we go. Now, how many people remember simple and compound interest? Okay, when the way that IB does it, it's pretty much the exact same idea. It's just that certain variables are going to be changed. Like, for example, when you were taught this, hopefully in Algebra 2 or maybe in Algebra 1, depending on your teacher, you probably recognize it as A equals P, the principal you start with, times 1 plus R divided by N to the NT.
Yes.
Okay, so typically when people think of compound interest, you know, that is the formula that we use, but you're going to notice that we kind of switch things around here. What we used to know of as N, the number of compounding periods, that's now going to be called variable K. N is actually the number of years. Okay, so don't want to get too far ahead of myself. Let's just take a look at what we got here. Interest, the amount charged when money is borrowed or lent, or the amount paid for money invested. Okay, there are two types, simple and compound. Simple interest is usually calculated as a percentage of the amount borrowed, okay, which we call the principal. All right, so I is the interest paid. Okay, that's the amount that you've earned at the end of whatever time length you've got. P is the principal amount invested or borrowed. R is the interest rate. T is the time period for the loan or the investment, how long it lasts. Now you'll notice there are two formulas here, and the difference is your interest rate. If you're going to use I equals PRT, okay, you go ahead and plug that in as a decimal value. Okay.
So they're the exact same.
They're the exact same. And you'll notice here, while it's the same formula, they're just using C for the principal amount. Okay, so what they're telling you here is that R is still your interest, but it's the actual percentage. In fact, how would you convert a percent to a decimal? You divide by 100. So that's why we have the formula set up this way. And here, N is just the number of time periods. Okay, so personally, I like to go with I equals PRT just because I think it's way simpler. But I mean, either one of these is going to work. So let's look at an example here. A family invests $1,250 in an account that pays 6% annual simple interest, and there's the key word, annual simple interest for 7 years. Find the amount of interest paid over this period. Now, typically what people like to do in these problems, you know, you're trying to find the amount of money that we're going to have at the end of the investment. But some of these questions can be tricky. This one says find the amount of interest paid. Okay, so like on a lot of these, when we start getting into the compound portion of it, we may have to think, do I need to subtract off the original principal in order to see the amount that I've earned? Does that make sense? But here, I mean, that's what the formula, bless you, is giving you. The interest is equal to PRT. So how much are they investing? $1,250, okay, times 6%. Now, if I'm going to use this formula, okay, I'm going to go ahead and make sure that's a decimal, okay, because otherwise, if you leave it at 6 in this formula, it's actually going to take it as what? 600%, and I would love to get a bank account like that. That would be amazing. But in fact, does anybody know realistically, like if you were to walk into a bank today, about what kind of interest you would get?
Is it like 1 or 2%?
Actually, you'd be lucky to get 1%. You might be able to get 2% if you go ahead and open like a CD or something like that. The difference between like a normal savings account and a CD is the bank offers you a higher interest rate to try and get you to, you know, invest your money with them. But the catch is that you can't touch it. There's going to be huge fees involved if you do try to pull your money out before a specific amount of time. And usually that window might only be a couple of weeks in the year, and they won't even go out of their way to go ahead and let you know that, because if you don't say anything, what are they going to do? They're going to take the money and they're going to continue with the investment, because they're going to use your money to make money. Anyways, okay. 2%?
2% interest is
It's really not good.
not good.
Well, I mean, when you think about it long term, I mean, you might be able to supersize after a while, but that's about all you're going to be able to do.
$2 extra a year that you're not thinking.
Yes, well, that's true. I mean, anything more than you had is good, but I miss the good old days where you could go in and get like 4 or 5%. Way back in the day. Anyways, and then we want to multiply that by 7. Okay, so let's see here. Let me go ahead and take this off. So we had 1250 times 0.06, and then we're going to multiply that by 7. Okay, so how much interest are they going to earn after the 7 years? 525. Okay, so it took 7 years to earn $525, and think about it, you already put in 1250. Okay, so I don't know. Some people might think that would be worth it. Some people might not. I mean, 525, that's just under half of what you started with. So I guess maybe the glass is half full. Okay, let's see here. Okay, and now we have compound interest. Simple interest implies that every time interest is paid is withdrawn by the investor. This leaves the principal untouched for the period of the loan. It's more common that an interest is added compounded to the principal so that the principal grows during the period of the loan. You're earning interest on your interest, and that's really what you want to do. In fact, personally, I think the most important component here is going to be time. Just leave it alone. Don't pull money out. Just let it continue to grow, because the larger it gets, the more you're going to earn. Some formulae for computations with compound interest are. Now, this here, it's starting to look like the formula that we are somewhat accustomed to. C is still the capital, the amount that you go ahead and invest. Now here, R is still the percentage because you're dividing by 100. That changes it to the decimal. N is going to be the number of years. So you'll notice they're taking this formula and they're subtracting C. So if you go ahead and subtract off what you initially invested, that difference is just the amount that you earned. Now, really important to keep in mind, this is compounded annually. So how many times a year is that? Just the once. Okay, just the once. Okay. You'll notice when we start compounding it multiple times a year, or even continuously, the more you compound, the higher your yield is going to be, but the growth is going to slow at a certain point, especially if you start really studying exponential growth on that. Okay, so let's see. I got 207. I'll tell you what, we'll just go ahead and stop there. Okay. I think we at least got it started for today, so that's good. Okay. And did everybody get a copy of the homework assignment? Okay, due Tuesday. Tomorrow you have your quiz over systems and quadratics. Okay, okay.